Hello, everyone, and thanks for being here. My name is Rob. I'm a developer relations engineer at Google, and I work mainly on large screens and foldables. So, before we start with the talk, who's scared of activity recreation? Please raise your hand. Yeah, great, I'm going to scare you even more. Oh, wait, no, probably that's not the right thing to do. Well, let's see, probably not. I don't know, we'll see. OK, so first, this talk is going to be divided into two main areas. The first area is related to static stuff. So what configuration changes are, and what they represent at any given point in time for your app. The other part is anything that is dynamic, or actually how, when, and why size configurations happen. OK? All clear? Great. I know that it's right after lunch, but please just nod, otherwise I don't know if I'm doing, so please help out. OK. So first of all, for anybody that is not watching this talk in this moment, this is accurate as Android 14. So, well, that's the ground level, OK? Perfect. So we all know that configurations are a fundamental aspect of how Android applications behave, because configuration describes many aspects of the user settings and the device configuration that are important when you're rendering your app UI. For instance, it describes the font scale, the dark mode, the locale, the dock state, physical keyboard, and many more. So if you think about anything, probably it has something to do with the configuration. OK, the pieces of configuration that we are focusing in this talk are all related to size. Or actually, rather than the size, how much area the activity has to render on the display. So apart from these values, who thinks that your activity, even when not in multi-window mode, takes up the whole area on your screen? Please raise your hand if you think that your activity takes up the whole space. Well, you all know the answer, so what I'm doing here. OK, so first, well, we are all scared of activity recreation. So if you want to opt out activity recreation, you have to add these 4 flags to your manifest that are orientation, screen layout, screen size, and smallest screen size. If you want to go on the safe side, you also add keyboard and keyboard hidden. So if someone attached or detach a keyboard, you're safe. But that's for another talk. OK, so at this moment, we opted out of activity recreation, so the talk is done, right? No, you should say no now. OK. Now that we have all the definitions for this talk set, let's start with things, well, everything that is static. So again, anything that is verified in a specific moment of time. So if you look at these 4 fields of the configuration, you see that there is a screen layout, the width of the screen in DP, the height of the screen in DP, and the smallest width of the screen in DP, right? But actually, the name is somehow misleading, because rather than the screen per se, this value represents how much space you actually have to render your app. So basically, they don't really match the size of your screen, but rather the amount of area that the user or the system gave to your app to render. I see your puzzled faces, so that's a very good sign. It means some explanation, so here. Let's go. So this has an important implication. So we know that different activities might have different configurations. But that means that even different activities from your own application can have different configuration. Or even worse, if you actually enable multi-instance, the same activity running in, well, in parallel in this case, may have different configuration. It's amazing, right? So you need to be aware of what is the right configuration for your activity. So rather than thinking about the configuration representing the device screen, you should think of the configuration to something that describes the window in which your activity is running, with a small caveat, which is that you don't really have the absolute values. They are rough estimations of the space that you have. So let's look at a couple of values and explain why. So for the next few slides, we're going to use this very simple compose code to help us understand what we mean with everything I said so far. So let's run this on a Pixel tablet and see what we get. So let's start from the last one. Orientation is landscape, right? That's correct. That's what we expect, right? That's landscape. Perfect. But well, there's something wrong there. Like, I see two dimensions. Like, the width is 1280, and the height is 744. But the smallest screen width is 800. Does anyone know why? Because I don't know. So if somebody knows, that would be really appreciated. Otherwise, we're going to discover it later.
Maybe it's a value for portrait mode?
Come again?
Maybe it's a value for portrait mode?
Not quite. Oh, but nice try. OK, so we don't know why that happens. I think we need to discover that, right? Yeah, let's try. So the answer to that is insets. So by default, the system UI is displayed on some parts of the screen. In this case, we have the status bar on top and the navigation on the bottom. So the screen width and the screen height will actually give you the number, which is the dimension, minus the insets, which in this case are 56 dps. So at this point, it adds up, because 744 plus 56, it makes 800, right? The width was OK, so we're done. Not quite. Because now, we want to rotate the pixel, because we rotate devices. So please don't lock the orientation. That's bad. Don't do that. Oh, wait, this is weird. Now it looks like the screen height changed. And that's because of? You shouldn't answer. You know the talk. It's because of the? Come on, the height changed. I want to hear your voices. Great, it's because of the insets. But of course, well, the smallest screen width didn't change because, I mean, the screen is that. So you cannot really change when you take the full screen. That's the minimum that you get. But of course, the screen width DP changed because now we don't have insets on the side. We don't have display cutouts. OK? All clear until now? Because later is more confusing. So I want to make sure that everything is clear now. I see somebody nod. Thank you. OK. So just because we want to make things even more complicated, we have to note that insets are dynamic. Let's take this example on the Pixel 7 Pro. Well, here things change again. And that's because, actually, the navigation bar changes inside. So we see that when we have the swipe navigation enabled, the insets are smaller. And when we have the 3 buttons, the insets are bigger. So we get different values. Again, the smallest screen width doesn't take into account that, so that's fine. The other two do. So that's something to keep in mind. Now, let's rotate the Pixel 7. And here, we have a display cutout on the side, so it's even more confusing. So again, if you see, it doesn't match, well, the smallest screen width DP doesn't match any of the other value. But they are all still telling the truth. We just need to adjust for which one it is, but that's how it works. So whenever you want to get the size of your window, you have to take into account that screen width and screen height actually count the cutout. So you have the whole amount of space that you have. Even if you go edge to edge, it will still count the insets, because insets are quite important. While the smallest screen width doesn't count the insets. OK. Now, let's take a closer look at orientation. Because, well, usually, if we have only one app running, well, that's pretty easy. I mean, if I keep my phone in landscape, that's landscape. If I keep it in portrait, that's portrait. So if width is bigger than high, it's landscape. Otherwise, it's portrait, right? Make sense? Yeah, but things are a bit more complicated when we go into multi-window or in the inner display of a foldable phone. Why is that? Well, because the clear distinction that we had so far, like one app running, taking up the whole space, so it's either landscape or portrait, well, starts to go away as width becomes very closer to high. Let's see an example of that. So we have these two boxes. They are pretty similar, right? And yet, one is landscape, and the other one is portrait. Even though, for us, it doesn't really change much, because it's one DP moving from one side to the other, one is still landscape, and the other one is portrait. So the lesson here is that when you're thinking your layout, depending on a specific aspect ratio, to make some overall layout decision might be tough. Because here, nothing changed. They're not square, but one is landscape and one is portrait. Do they really change much? Not really, but still, they're two very different items. And yet, there is something that goes back to insets, and that's really funny. So this is the screen of an Oppo Find N, which is a foldable that, when it's unfolded, it's actually a almost square display. Well, when you open the device, it's almost square, but it's still portrait, for the same reason we saw earlier, like 1 dp difference. So why is this happening? If it's portrait, we would expect that the width is smaller than the height, right? Yeah. Insets. Since the width, the height actually counts the insets, what we get is that the screen height is actually smaller than the screen width. That's amazing, right? Yeah, say yes, please. Perfect. Anyway, this is still identified as a portrait screen. So this is very confusing, right? Perfect, because we are getting even more confused. So let's stop talking about insets. We had enough. And let's start talking about rounding. So screen width DP, high, smallest screen DPs are all integer values, right? We all saw that they are integer. However, different displays might have different densities. And the apparent density of the display is also something that the users can customize. So Well, this is where the configuration.density DPI comes in, because it returns the integer value describing how many pixels correspond to a single DP. So far, so good. We have integer on one side, we have integer on the other side. But unfortunately, maths doesn't really like us, and it happens that when we do some operations, we end up with a float value. So let's see how that works. So we want to calculate how many DPs we have. So this is very complicated for me to explain. So we take the pixel, and we multiply by a factor of 160. And we divide it by the density DPI. So in this case, a pixel would be 1 dp. So that's the easiest case. So if you have a density of 320, 1 pixel will be 0.5. If we have a density of 80, it will be 2. OK? So when we run these, there is a chance that we actually have a floating value. But still, all dimensions are integers. So of course, that works the other way around. So we can rearrange it to get the pixels out of the DPs. So yeah, if you're familiar with that constant in compose, it's basically what the part of the formula that we just saw. But let's see why this is important. Let's take a look to the Pixel 7 Pro. It has a physical size of 1440 by 3120, and a density DPI of 560. So that means that in portrait, the Pixel Pro has a width of 1440 per multiplied by 160 divided by 560, which gives us roughly 411.4286. But when we want to use that dimension, which is the width of the screen, well, this is rounded down to 411. And since width and height have been rounded, they will be slightly wrong. Because, of course, that's how rounding works. If you have a precise float number and you round it down or up, well, the integer has a small error. So if we use these to make a box and actually plot something on the screen, we see that there will be something off. So if we do the same, but back to pixels, so we take the value that we had before, 411, and we multiply by 560 and divide by 160 to get back the pixel from the DPs, we start seeing something weird, because we know that the width is 1440, and this is 1438.5. This is going to be rounded to 1439, but it's still 1 pixel off our original display size. So what happens is this. Everything works, right? Let's zoom in. Yeah, we still cannot see it clearly. Here. This is what happened. So that's because we rounded the number twice, and we introduced a small error. It's still 1 pixel, but it's very noticeable when you look at a screen that does that. So are there solutions for that? Luckily, yes. First, when you need to calculate the size of your windows, use this library, because internally it does a bunch of calculation that will give you a better estimate of how much space you actually will have. It's important that you use the right UI context, that means your activity context, rather than your application, because with your application you wouldn't get the right values. And internally, it does a bunch of logic to give you exactly the measures that you're looking for. And also, if you listen so far and still think about getting the real size of the screen, please reconsider doing that, because windowing is becoming more and more dynamic. And these are just small examples, but when you run your app on, for instance, on a Chromebook where you have freeform, that's going to be even more complicated. So if you need to know what kind of screen size, or actually what kind of area you have on your screen, rely on these and on window size classes. If you don't know what they are, just ask me afterwards, and I'll be happy to answer that question. I just wanted to mention it. OK, so just to give you an example of what is the logic that it runs inside, well, this is a bit of the logic that that function runs. It's important noticing that we have the local configuration .current in the first line, because it will trigger a recomposition, so it will get the right values right away. OK, now we saw everything static, so we're pretty much scared so far. Let's see how things changes. I'll promise it will be even more scary. No, I'm joking, don't leave. OK, so how do we trigger, for instance, an activity recreation? Well, that's easy. I just rotate my device or fold and fold and change the window size in multi-window. Right? Let's see how we can actually deal with that. OK? Because that's the scary part. So, as a refresher, when a configuration change happened, by default, the activity is recreated. And your activity will go through the onPause, onStop, onDestroy, and the new instance is recreated. It goes through onCreate, onStart, onResume, with the state and everything. And everything related to size actually follow this exact path. Well, at least it did, until API 24. So things changed. Wait, I touched something I should not. OK, back to here. OK, before we start thinking how things really changed, we need to explain why size changes are special. They are a special case. Because we have a concept of significant configuration changes. That means that a configuration change in size is significant only when you change at least one of the buckets of your resources. So if you change anything related to size, but your app stays in the same bucket, so it will go fetching the resources from the same bucket, that's not a significant size configuration change. OK? So let's see a much clearer view of that. So as a simple way of seeing this, we only have width and height. These are all the possible combinations that our app can be in. So we have a huge display, and we run the app on this portion of the screen. We are, let's say, at the beginning of the range of the width 400. We start dragging, but we are still in the same bucket. All these configuration changes are still happening, but they're not significant. They will become significant as soon as we cross the border and we go to 600. OK? Clear? Perfect. So starting from API 24, only significant size configuration causes an activity recreation. OK? So only if we change the bucket, we'll see our activity being recreated. Again, that doesn't mean that a configuration change is not happening. It's still happening. It's just not significant enough to trigger a full activity recreation. OK, let's continue. Well, this is even more clear when we see this app running on Chrome OS. So as you see, we are changing the size quite a lot. The number of configuration is increasing, but the number of recreations, it's actually smaller. So we noticed that we went up to 100 configuration changes, all related to size, but only a bunch of activity recreation. This is exactly what we meant so far. The main implication is that, in general, you can just rely on activity on create to run arbitrary logic on the configuration or on the window size itself, regardless of whether you are specifying 100 config changes or not. So the idea is that I need to be aware of configuration changes. How I do that? Well, first, you need to run the initial logic in activity on create, of course, because we want to render whatever we need to render. And then we want to run something whenever the configuration changes without recreating the activity. The most natural place you'd expect to run this logic is the onConfigurationChanged in a method in your activity. This is the primary method for getting a callback when the configuration changes when opting out of recreation with the flags that we saw earlier and we saw here. And this works until API 30. So we already have two thresholds, API 24 and API 30. But the bad news is that on API 30 through API 33, the activity method onConfigurationChanged won't be called in case where a configuration change was only a significant size change and where you're not opting out of activity recreation. So basically, if you are in the first scenario, so you don't declare any flag, that method won't be called. So basically, the activity is not being recreated, so you're not passing through on create, and onConfigurationChanged is not being called because, well, we didn't really specify how we want to opt out of activity recreation. So it's being complicated. And that's even worse, because in API 31 and some version of API 32, even if you're opting out of activity creation with all the flags, a configuration change is still happened. And even if you're explicitly asking to get that method called, well, that method is not being called anyway. So there is a way out. There is a way to get notified that a configuration change happened in all the situations, and that is using this view onConfigurationChanged method on an attached view. So this code here is the most reliable way to be notified of every configuration change, so that basically you need to create a view, override the onConfigurationChanged method, and that method will be called when the configuration is changed, even if that doesn't recreate the activity and it doesn't call the activity onConfigurationChanged. So for the best compatibility, if your app uses views, well, this is what you should be using as well. In Compose, you don't really need to do the extra work, because the local configuration.current method is updated using the view onConfigurationChanged internally. So is fully aware of any configuration change. So any calculation done using the local configuration.current will be performed again if the configuration change without activity recreation. And that's why we actually call that method as the first thing in the calculate window size class implementation. Because insignificant and significant size changes are based on resources, if you have, for instance, a Compose app that doesn't rely at all on qualified resources, you will have many more configuration changes that are classified as insignificant. Because again, significant size configuration changes are based on the fact that you change the bucket. But if you never change the bucket, they cannot trigger. So you may run in the issues that we just mentioned. So going back to this amazing table one more time, with API 34, these inconsistencies will be ironed out. And we will return to the behavior from API 24 to 29, well, it gives us a way more predictable behavior. Either the activity is recreated, so we go through the onCreate method, or both the activity and view on configuration changed are called. So this is the ideal scenario. OK, so we now are fully aware of everything that works and how it works in the configuration change. And if you want to calculate the window size, please use the Windows metrics calculator and the window size classes. It's very important, and it's the easiest path going forward. And remember to use that other method until API 34. And inside that, remember to call the window metric calculator. So the goal here is please call the window metrics calculator. It's very helpful. Do we still have time for questions? Okay. Thank you, everyone, for listening. If you have questions, please ask. I don't bite.